This tutorial will show the workflow of setting up milling operation of holes. The example contains a 3/4 inch piece of plywood as a stock, with multiple hole types being milled. First, set up the stock. In this case, the stock has already been modeled and can be inputted through the stock from selection button. Now that the stock has been set up, we can then begin assigning the milling operations. There are two types of hole conditions in this example that will use 2-axis milling operations and the holes milling operations. The holes milling operation can be set up as a series of points along the stock, if the tool bit is coordinated to be the intended diameter. In the cases where the diameter of the holes are slightly larger than the tool bit that is being used, then the 2-axis milling operation can be used instead. Let's begin by creating the toolpath for the holes milling operation. Click Drill under the Holes option. From this, select the points in the model that are intended to be drilled. Once the points are selected, the points should appear on the window. Here, they can be selected individually and removed if they are not needed. Moving on to the tools, we will select the 1/2 inch downcut tool bit for the holes. Under Feeds and Speeds, parameters for controlling the tool bit are modified here. These parameters may be modified during coordination with the workshop staff, if need be. I'll be going over briefly the functions of this page with reference to the diagram on the right. Plunge is how fast the tool will approach the material before it begins cutting. Approach is a small transition from the plunge of the tool before the beginning of the cut. Engage is the motion of transitioning into the stock. Cut is the actual cutting of the stock. This could be used for a roughing pass, a finishing pass, or other types of cuts. Retract and departure are similar to approach and engage, and transfer is the movement from one cut operation to the next. The clearance plane is typically defined automatically by the extent of the stock. This will define the height of the transfer cut operation between cuts. Under the cut parameters, we'll select standard drill. There are additional options on the drop-down of drill types, but for this exercise we will stick with the default. The drill depth will be set to 0.77 inches in this case, just to extend slightly past the extent of the stock, which is set at 0.75 inches. Again, parameters will be reviewed with the workshop staff before the intended date of CNCing, as modifying these parameters will need to be coordinated with the CNC machine at that time. Sorting dictates the order at which the cuts will be executed within the overall milling operation. In this case, we will set it up at minimum distance sort, so that the shortest distance between the cuts will be taken. In this application, the difference between is negligible, but if this example was arrayed multiple times, the order at which the cuts will occur would matter. Once the parameters are set up, we can then generate the milling operation. Now that we have our holes operation generated, we can now create the larger holes with the 2-axis operation. Under 2-axis, we will select pocketing to create our holes, or in this case, pockets. Followed by the selection of the curves, the tool bit, feeds and speeds, and clearance plane will be the same as before. Under cut parameters, we will set the global parameters to be 0.01 for the tolerance, and in this case, 0 for the stock. For the cut pattern, offset will be assigned. The cut pattern dictates the path the tool bit will follow during the cut. Because we are using a downcut tool bit, we will set climb for the cut direction parameter. The rest we will leave as is for this example. For cut levels, we will assign the location of the cut geometry to be at the top, so that the specified depth will start from the surface of the stock. Since we are simply creating holes, we can set the depth to be slightly deeper than the stock to ensure that it will cut through. Pocketing entry and exit and advanced cut parameters do not need to be addressed in this tutorial. And for sorting, we will assign the minimum sorting distance again. After that, we can generate the milling operation for the 2-axis command. Now that we have our milling operations for our cut, we can run them through our simulation to see if any collision errors or anomalies occur. Reviewing the simulation, it appears that no problems are present with the cut, and we can now post our milling operation into G-code.